In college algebra, we started 3.5 rational functions. And the definition for rational, like do we have a rational function, is a scenario when x is in the denominator. So we of course have a fraction, but the key part to this is that x is in the denominator. So think for a minute, look at 1 over x. What would be a bad number to plug into the denominator or into this function? And it would be 0. So when we look at the domain of this function, we can plug in any number we want except 0, because if we plug anything else in, we're going to get a result. But if we plug in a 0, we get undefined. Another way to look at this is by looking at the graph. So let me back out of this and open up the graph. So here I am in the graph function. I can type 1 divided by x, and I get a really weird looking graph. It almost looks like 2 graphs, but it's just 1. And it's because as you read it left to right, it skips 0. So it never actually crosses that middle spot. So right here, there's actually this thing called an asymptote. If you can see my green line going down, it's hard to see with the axis there. There's also a horizontal asymptote on the x-axis itself. So it never crosses those green lines, and it's all because of that fraction and x being in the denominator. In the next question, well, first let's graph it on the other page. So domain was any real number except 0, and our graph looks something like this. They should be perfectly symmetric. I tried, but it's not perfectly symmetric. And as I scan across the x-axis, what number does it get close to and approach? But it actually jumps, and that is 0. We already pointed that out. Okay, the next 2 questions are difficult. As x approaches 0, and it says to the left, so we write a little negative sign above the 0 to symbolize left. So imagine I'm on that leftmost arrow, and I'm running across that green line. It's eventually going to drop straight down, right? So we say f of x approaches negative infinity. So one more time. I'm on the leftmost arrow, standing on it, and I'm going to run to the right towards 0. That line ends up shooting straight down to negative infinity. And then, if I'm standing on the arrow furthest to the right, as x approaches 0 from the right, that graph is going to shoot up. This one's weird because I'm going to go right to left. So the arrow furthest to the right, I start running left along that line, and it shoots up, so it is approaching infinity. All right, let's look at another one. We have 1 over x minus 3. Think for a minute, what would be a bad number to plug in? If I plug in a 3, that's going to make that denominator equal to 0, right? So that's what we want to exclude from the domain. Another way to see it is go to the graph. I have number 1 still in here, so just hit tab, and we can type 1 divided by, now be careful here, I want x minus 3 in the denominator, so I'm going to use a parenthesis, x minus 3, and I got it. So that blue graph scooted 3 units to the right. And if you look at 3 on the x-axis, it never actually touches it. It gets really close to it, but it doesn't touch it. So if I was to draw a line, that asymptote that I was talking about, it is right here, and it cuts right through 3, because that dash is 3. There's still a horizontal asymptote right there. Only look at the red and the green, ignore the blue. All right, let's graph it on the notes. So I have this horizontal asymptote at 3. Or sorry, that's vertical, mixing those up. Horizontal is the x-axis itself. And the graph does something like this. Another way to think about the domain is to find domain, set the denominator equal to 0 and solve. Exclude the answer from the domain. So the denominator is x minus 3 equal to 0. Solve it. I get 3. That's what I don't include in my domain. So domain is all numbers except 3. All right, let's try one more. Very similar to number 1. This time it's 1 over x squared. And just like number 1, if I was to plug a 0 in there, that would be really bad. We can set the denominator equal to 0, like I suggested in the last problem. It always works. Square root both sides in this problem to solve, and we get 0. So the domain is all numbers except 0. Let's look at the graph. So on the graph, let's get rid of all this stuff. We have 1 divided by x squared. This time that third quadrant flipped up into the second quadrant, and it's all because of this squaring right here. If I plug in a negative, it squares it so it makes it positive. So even if I plug in a negative x, I get a positive y. And that's why the graph becomes what it is. So right here, let's draw our graph. Looks something like this. There are some asymptotes on here. Right there. And right there. We decided a second ago that the domain is all numbers except 0. What is the graph getting really close to but doesn't touch? Same as before, 0. That question is as x approaches 0 from the left. F of x approaches, so I'm on the furthest arrow to the left. I'm standing on that. Oh, I don't have an arrow there. Let's draw an arrow. So I'm on that arrow right there. And I run on that red line to the right. I'm going to go to infinity. On this question, as x approaches 0 from the right, Now I'm standing on the arrow furthest to the right over there, and I run left up the red line. I'm going to approach infinity again. All right, hope that makes sense. I will see y'all later.